In this video, we are going to see the topic under for the linear algebra, which is Gauss-Jordan method. So, previous video we have seen Gauss elimination method. That means how to find a solution of a system of equations, right? So that is what we learned in the last video. So same thing we are going to do, just the extension part. So there the aim of a Gauss elimination method is nothing but to make it a upper triangular matrix, right? So here the aim of the Gauss-Jordan method is nothing but is reducing the coefficient of matrix capital A to be diagonal matrix. So first to eliminate your upper triangular, what we have followed in the Gauss elimination method, same elimination process we will follow here also. So once you reach it as how we have done in the Gauss elimination method, same way, again we are going to make it as a diagonal matrix. Okay. So we'll go with the example to understand how we are making a diagonal matrix. Okay. The questions will be the direct one. Solve the following system of equation by Gauss-Jordan method. So sometimes it may Gauss-Jordan eliminations method. So the question is x plus y plus z equal to 9, x minus 2y plus 3z equal to 8, 2x plus y minus z equal to 3. So what is given? It is 3 equation has been given. First what you have to do? To writing the solutions, you have to start with the augmented matrix. So when you are writing the figure of A and B, we will call it as an augmented matrix. A is nothing but the coefficient matrix which you have in the left side. B is nothing but it's in the right side values, right? So first you write it from the first equation. X coefficient 1, y coefficient 1, z coefficient 1, and it is a b value is 9. Similar second one, 1, minus 2, 3, 8. And third one, 2, 1, minus 1, 3. Okay. So this is our augmented matrix. So what you have to do? First you have to eliminate the second row first element, third row first element, and third row second element. These three positions we are going to make it 0. After we are going to make it for your upper terms also we are going to convert as 0. Okay. First we are making upper triangular, then using that we are going to make it as a diagonal matrix. Okay. So you can see that the augmented matrix of A and B is equivalent matrix of first row we are going to keep as it is, and it's making a second row 0. I have already 1. So to make it 0, what I need? Just a minus 1. So what since we have already discussed it, the first row first element to convert 0, always you are supposed to use in the first row. Okay, in the which row, second row or third row, whatever row, the first element of the particular row, we need to make it 0. We are supposed to use it in the first row. Okay, so you can see just R2 implies, how it is a new R2? R2 implies my old R2 value minus R1. What is that? 1 minus 1, 0, and here minus 2, minus 1. It will be a minus 3. See, the next one, 3 minus 1, I will get 2. The next one I have 8 minus 9 will be minus 1. Okay. Similar, you can go your third row. What is that? When it's coming third row, I have a 2 here. Okay. So I should make it a 0 in the third row first element means I need a minus 2. So use your first row. Completely I am going to multiple with 2R1 and subtract with your R3. So R3 implies R3 minus 2 into R1. So multiple with 2 here it will be 2, 2, 2, 18. Okay. So 2 minus 2 will be 0, and then you have minus 1 because 1 minus 2 will be minus 1, and then minus 1 minus 2 will be, I'll get minus 3, and then next one 3 minus 18 will be minus 15. Okay. So now next one, what is that? I have to make it 0 for this minus 1 position. You have to use which row? Second row, because when you make it in second element to 0, always you have to prefer to use only second row, because again the 0 should not repeat once you converted 0. Okay. Now what you have to do? What is that we made it? You have a term of converting zeros. So 0 minus 3, 2 minus 1. The next one you can convert it. I'll get 0, 0, 11, 44. Okay. So now you can go with the next one to convert the 0 of your first row third element and the second row third element, you are supposed to use it here third row. Okay, here also you can divide by 11, it will become 1 and 4. Use the third row to make it the first row and second row third element to 0, and similar you are supposed to use it with your, what is that, to convert a second element to 0, use your second row. So using that, what I will get, R1 implies R1 minus 5 R3, then R2 implies R2 minus 2 R3. You can get the diagonal matrix like that, 0 3 0 0 6, 0 minus 3 0 minus 9, 0 0 1 4. Now you can see that the augmented matrix how we have got it. Okay, so once you reach it that like this is a diagonal matrix, so it is repeated steps we have written here. So you can see the diagonal matrix. So what you will get, you can go with the substitutions method. So what you can substitute, first one 3x, right? So from the first one 3x is equal to 6, and second one minus 3y, because x is also 0, z is also 0, minus 9, and the next one z is equal to 4. From here minus will get cancelled, 3 will get cancelled, I will get 3. So y is equal to 3, z is equal to 4, and here what is that? 3x is equal to 6 by 3 will be 2. So that's why x is 2, y is equal to 3, and z is equal to 4 has come. Okay. So just you can make it a diagonal matrix. You can avoid the backward substitutions which you have learned in Gauss eliminations method. Okay. So now we are going with one more example to understand the Gauss-Jordan method. Okay, so apply the Gauss-Jordan method to solve the system of equation which is 2x plus 5y plus 7z equal to 52, and 2x plus y minus z equal to 0, x plus y plus z equal to 9. So interchange the equation 1 and 3, because you can see first element in the every row must be 1. It's not like a must be 1. If it is a 1, it is easily we can able to do the row elementary transformation, because to convert in the first element in any of the row, we are supposed to use in the first row. Okay, so for that reason you can interchange it, third equation and the first equation, it will be easy to do it. Okay, so equivalent matrix of A and B, which is 1 1 1 9, 2 1 minus 1 0, and 2 5 7 52. So this is after interchanging the augmented matrix. Okay, now to make it a 0 of second row and third row, we have to use the first row, which is R2 implies R2 minus 2 R1. So what will happen? Multiple with 2, 2, 2, 2, 18. So 2 minus 2 0, 2 minus 2 0, minus 1 minus 2 will be minus 3, and 0 minus 18 will be minus 18. That was has come 0, minus 1, minus 3 and minus 18. Next one, third row, again you are supposed to multiply with 2. So 2, 2, 2, 18. So what is that? 2 minus 2 will be 0, 5 minus 2 will be 3, 7 minus 2 will be, what is that? It will be a 5, and then next one 52 minus 18 will be 34. That was written 0, 3, 0, 3, 5, 34. Now you can see with your next step what you have to do. This 3 position I should convert 0 to using a second row. What I am going to do that, just you can multiple with that 3, and then you can able to convert, you can get the answer. So meanwhile what I am going to do, I am going to convert the first row also to 0, because only I am using the second row. Okay, so parallelly you can go with your third using the second row, first row second element, and third row second element also I can make it 0. To make it a second element 0, what I did, R1. So R1 implies, just you can add R2 plus R1, this also will convert. So now 1 and minus 1 plus 1 will be 0, minus 2 plus 1 will be minus 3 plus 1 will be minus 2, then minus 18, right? So I'll get it for here, minus 18 plus 9 will be minus 9. Okay, now you can see here the third row also, what is that? I need a 3, so just multiple with 3 in R2 and just add it. So 0 0 will get 0, minus 3 plus 3 will be 0, and minus 9 plus 5 will be minus 4, and then minus 18 3 is into again plus 34, I'll get minus 20. Okay, so this is here parallelly we did for the 0 for first row second element and third row second element also, right? So the next one I should convert to 0 for here first row and second row third element I'm supposed to convert. Okay, so before that I'm going to make it simple for a third row, because I'm going to use only the third row. Divide by minus 4, so it will become 1 and 5. Now you can see just I can go with 2 into first one and 3 into for here 2 into R3 I can subtract it, add it with the first row, it will go, and similar 3 into R3 and add it, it will go for 0 here. Third row, second row, third element. So that is what is written. R1 implies 2 into R3 plus R1. Okay, so you can multiple 2 and 10. So 1 will remain same, 0, 2 minus 2 will be 0, and then 10 I'll be having it, the term, what is that, which you have a remaining terms is a minus 9. The next one I have it for the element, here we made it 0 for this, so 1 minus 1 0, then I'll get minus 3, because you can take it with R2 implies 3 into R3 plus R2. So you can see that, so what you have it here, it's supposed to be 0, and then you will get a term. So what I have it here, I have a 10, alright. So 10 minus 9, it will be, it's supposed to be 1 here. Okay, so you can correct it, this will go for 0 and this will be 1. Okay, so this is their answer. So now you can see that what I have it, so this will be 0 and this will be 1, answer. So from this substitution you can go x is equal to 1 minus y is equal to minus 3. So it will be y is equal to 3 and z is equal to 5. Okay, so this is for your solutions after using your Gauss-Jordan eliminations method. So generally you can go with the Gauss-Jordan method, will be used to find your inverse of a matrix. You can use a best tool which you can able to easily find your inverse by using a Gauss-Jordan method. Okay, so that's all. Thank you.